platform engineering and AI aren't just intersecting, they're actually reshaping each other. Most platform engineers are already using some sort of AI daily, and nearly every organization we've surveyed says that AI is critical to the future of this discipline. But what's important to realize is what matters isn't whether AI shows up in your platform, it's how. This isn't about bolting an LLM onto an existing platform or treating it like some other kind of workload if you're building AI products. What's happening is an actual split into two distinct paths, and most platform teams are going to need to navigate potentially both at the same time. One path is going to use AI to make platforms smarter, and the other is going to build platforms that make AI usable at scale. So understanding the difference is what determines whether your platform initiative leads or lags over the next few years in this avenue. And that's what we're going to focus on today. So there's two paths, AI-powered platforms versus platforms built for AI. So let's separate these because they actually solve two very different problems. So AI-powered platforms are the ones that use LLMs and agents to improve the platform experience you already have. They may look like generating infrastructure or configurations from natural language, intelligent troubleshooting that points to a likely root cause, or even security policies that flag risky changes automatically. These capabilities will serve your existing users, so developers, SREs, and even platform engineers. The goal here is simple: reduce cognitive load and speed up workflows you already support. This is, by definition, an evolutionary change. But when it comes to platforms for AI, these are something else entirely. These exist to support AI and machine learning workloads directly. So this is stuff like GPU orchestration, model registries, feature stores, experiment tracking, long-running training jobs. But the biggest shift is really in who you are building these platforms for. Now, outside of developers, you have data scientists and machine learning engineers because they are a whole different animal to consider. They don't work like application devs traditionally do. Their workflows tend to be much more exploratory and unpredictable, and also very expensive. These folks iterate really fast. They use non-standard tooling, and they consume massive amounts of compute resources. This is where many platform teams will run into trouble because it's an entirely different experience. So why do most platforms break under AI workloads? Over the past few years, the platforms that we tend to see are the ones that are designed for standard software delivery. So this is your CI/CD pipeline, it's Kubernetes, it's developer portals, self-service golden paths, all that fun stuff we always talk about. And those systems, generally speaking, weren't designed to support machine learning. When teams try to force AI workloads into platforms that are built for application delivery, friction will come on hard and fast. Shadow infra appears, governance gets completely bypassed, innovation slows instead of speeding up, and people get mad. It's not a tooling problem though, it's really just an architectural mismatch. This is why so many platform engineers expect AI to fundamentally reshape platforms in the near term to solve this problem. One of the biggest shifts that we're seeing is platforms becoming active participants in their day-to-day operations. So what I mean by that is things like AI agents that are starting to act like first-class platform citizens. They have things like permissions, quotas, policies, just like a human user, but obviously a little bit different. There's also the idea of a self-optimizing platform that can allocate resources dynamically, tune policies up in real time, and balance things like cost and performance automatically. So, for example, reallocating GPU capacity across training jobs, scaling down an idle notebook, and prioritizing production inference, all within a set of guardrails that are set and standardized by a platform team. This then changes what platform engineering means. You now need audit trails for agent actions, not just human ones. You need rollback mechanisms for automated changes. Human approval workflows for high-impact decisions now become very important. So this means that the platform team's role has to shift from being reactive to incidents to supervise intelligent systems that manage infrastructure on their behalf. Traditional layered architectures don't really work well for AI. Machine learning workflows aren't linear. Data scientists jump between exploration, training, evaluation, and deployment fairly constantly. They need notebooks, they need long-running jobs, data pipelines, and real-time serving, often simultaneously. So layered architectures will force sequential dependencies, and this creates bottlenecks. That's why our standard plane-based architecture is changing, and it's emerging specifically for AI platforms. Instead of traditionally rigid layers, capabilities are going to be organized into parallel planes like developer environments, delivery, data and models, compute, observability, and security. Each plane operates independently, but does intersect when needed. This allows teams to move quickly without fighting the architecture every time they try to do a new experiment. When we think about golden paths in this case, they are still very critical for AI, perhaps even more than they are for traditional software development. For AI and machine learning teams, golden paths might mean pre-configured notebook environments or templated training pipelines. I've even seen standardized deployment paths specifically for inference work. But just like building for regular software, these golden paths can't become cages. Teams need the ability to break out when they're doing genuinely new or innovative work. The trade-off here is clear. Leave the paid road, take on more operational responsibility. And this balance is how enterprises are going to enable innovation in this case without losing control. When it comes to governance, especially in AI, it's no longer optional. So new regulations and real-world risks mean that things like security and compliance really have to be built in from the start. And we talk about this for normal platform engineering anyway, but in this case, I think it's even more critical. AI is going to introduce challenges that traditional app security doesn't even begin to cover. It's things like training data poisoning or over-pessimistic agents or over-permissive agents that leak sensitive information. Non-deterministic outputs, this stuff breaks traditional testing models. Platform teams need policy as code approaches that define what is acceptable behavior and what isn't for these agents, that really control data access as well as permissions, and they do this in a programmatic way. This is also why model-agnostic design is so important. The AI landscape changes very quickly. Locking yourself into one model or provider is effectively a strategic risk. So having abstraction layers and flexible levels of orchestration are how you're going to stay in control as the ecosystem around your platform shifts. AI is changing platform engineering at a really, really fundamental level. Platforms are becoming smarter, much more autonomous, and more central to how organizations operate safely at scale. This isn't just about chasing a trend or some buzzwords, it's actually about building platforms that create leverage in a world where AI really isn't an option anymore. If you get these foundations right now, everything that comes next becomes significantly easier.